start, we have a guest, Luisa Conti. And who is Luisa Conti? So obviously it's not Czech. She's an Italian one. And if you will have a look on LinkedIn or something like that, you will find that she is a plant ecologist. She is focused on functional ecology, combined with community assembly processes. She also is dealing with invasive plants, and everything she will integrate in her talk. Now she's working in somewhere in in Prague, and partly in Chemnitz, I guess. And the home university is Rome. Yeah. So, Luisa, please could you present your research?
Thank you very much. So, yeah, as you already heard, I'm Luisa Conti, and I'm originally from Rome, where I did my PhD. I'm now working as a postdoc in Czech University of Life Sciences in Prague, and part-time also in the Institute of Botany in Třeboň. Right now I'm actually dealing with really different topics. In Prague I work with spectral diversity, so I work with spectral optical multispectral images from drones. But today I wanted to show you this little project that I have still with my colleagues back in Rome that I started when I was a PhD student, and that is still going on somehow, and I think it will be interesting for you because well, it deals with coastal sand dunes, and you don't see much of them in Czech Republic, so I hope you will find it interesting. In particular, I want to talk about the impact of an invasive plant of the genus Carpobrotus, which is really common in Mediterranean sandy shores. And so I want to talk about how it affects the plant communities that it invades. So let me start with a little bit of an introduction. I don't know how many of you actually know Mediterranean coastal dunes and all the communities that you can find. So essentially, sandy shores are in between the sea and the mainland, and as such, they are characterized by a really steep environmental gradient. And so these are communities that are in an ecotone. And I'm talking about communities in plural because, as I said, this gradient, really steep gradient of environmental conditions such as sea spray, wind, infiltration of salty water, and soil conditions creates really different microenvironments, so that different plants with different characteristics assemble different communities along this gradient. So it's what we call a zonation. So as you can see, there are different communities of plants, and sorry, I don't have a pointer, so I will just dance a little bit in front of you. So what we have here are the communities of the drift line, so these are the ones that are more exposed to the environmental stress. And then you have communities of the mobile dune, which is this first dune belt, which is called mobile because it's dynamic. So you have different effects from the sea, such as the wind that shapes these dunes, and because of the soil properties, these dunes are able to grow and to disappear with time. Then you have the communities of the interdune, which are where we found mostly annual species, but also perennial species. Anyway, these are normally grasslands, what we call interdune grasslands. Then we have a fixed dune, which is back here, and since the soil conditions are more stable, you can find woody species as well there. So normally, well-preserved coastal sand dune zonation will look something like this. You can see the different types of communities along the gradient. You can see the dunes. Unfortunately, most of the time they look like this. And this is because of all the disturbances, man-made disturbances, so that had nothing to do with the disturbance that comes from the sea, so anthropogenic disturbances that actually impact these communities, these natural communities, and ultimately these disappear. These disturbances are, some of them are quite obvious, such as the urbanization. When you build buildings in the beach, you cannot have plants anymore there. But then we have some other disturbances, such as the erosion, because of how we manage the rivers. Sediments are not able to go to the sea anymore, and therefore there is no sand to maintain these dunes. Also, touristic activities. The only fact that people go to the beach and step on the plants and on the dunes make the dunes disappear. We have also the beach litter, so all of the things that the sea puts on or gives back to the beach, both natural and also man-made, such as plastic litter, are a problem especially because of their management. So tourists and people like their beaches clean without anything. So finally, what the managers do is to clean mostly with mechanic means, and this ends up flattening the sand dunes. And last but not least, there's also the pressure of exotic species. So species that have been introduced, that don't belong to these environments or to these geographical regions, that are actually impacting the native plants. Some of these invasive species you might be familiar with. Some of them are really embedded into the imaginary landscape of Mediterranean places. So, for example, agave. It's really common in the south of Italy, especially in the coasts. And a lot of people that are no botanists, they think that it belongs to that region, but actually, as you know, comes from North America. Another invasive species that you probably have seen or that you know is Carpobrotus, or the Iceplant. It comes from South Africa, and it's also really common in the Italian coasts. This species Carpobrotus was introduced, well, mostly all of the exotic species in the coastal areas were introduced for ornamental reasons, and especially this plant as well, because as you can see, it has really pretty flowers. And but it also was introduced because of its stabilizing effect on the sand. It forms really tight mats, and therefore people, when it first was introduced, people believed that it was useful to have it so that the sand would stay. So they were trying actually to preserve the sand dunes. But actually, because of those tight mats, it's actually, and because of course of this clonality, this clonal vigor and reproductive vigor, it is quite competitive, and it can actually have some detrimental impact on the native plants. Why do I talk about Carpobrotus species? Well, actually, in Europe, we normally recognize two different morphotypes, and I say morphotypes because it's not clear whether they are two species separately or separate species or not. So one is what I call Carpobrotus acinaciformis, Italian pronunciation. In Czech would be something like acinaciformis. And then there is what I call Carpobrotus edulis. The thing is, apparently in Europe, Carpobrotus acinaciformis is not a well-defined species. It's normally called Carpobrotus affinis cynatiformis. So because there is apparently some hybridization processes going on between Cynatiformis and Edulis. So most of the times, apparently, what we see as Cynatiformis is probably an hybrid. This is not sure yet. There's some debate about this. If you want more information about these species in general, there is a really recent monography by Carpobrotus and other authors, and they also talk about these taxonomical issues. But generally, when I go to the field near Rome, I can identify two different morphotypes. What I call Cynatiformis has pink flowers normally, with leaves that are scimitar shaped, so a little bit more curved, and a little bit more symmetrical when you, asymmetrical when you see the cross section of these leaves. While Edulis has mostly yellow flowers, and the leaves are much straight, bigger some of the times, and are more symmetric when you see, more of an equilateral triangle when you see its section. So, of course, this plant, it has been around since the 1800s. It has been studied. Its impacts have been studied before, not only in Italy, but in other places such as in Spain and in France, California, in Australia. And some of the patterns that have been seen on the native communities that it invades is that generally these have less species. It also has been observed that the diversity of these species is lower, and also the functional and phylogenetic diversity of these communities, of the native communities, is lower. And this is because apparently there are some direct effects of Carpobrotus presence on the native species. Apparently, this is a species that, apart from competing, obviously, for space, it also is competing for water resources, which are really limited in this kind of environments where you have a substrate that is not retaining water at all, especially in the communities that are closer to the sea. Apparently, it's also competing for pollinators because of these really attractive flowers. And apparently, there is also it's also causing some impact on the ecosystem processes. So it also has some indirect effects that it's affecting the environment of these communities. So essentially, the most obvious one is the changes to the soil conditions, because it creates these really tight mats, and it also produces a lot of organic matter. So eventually, this matter will decompose and will create a higher soil pH and an accumulation also of nitrogen. Apparently, there is also this one article that says that the presence of Carpobrotus could actually, or is actually, increasing the soil salinity of the communities that it invades. So, the first thing that we did in my old lab in Rome was to check whether these two morphotypes were actually having the same impact. Because normally, all the studies that I cited before, they either focus on one, or they just use, they don't discern between the two morphotypes. So we wanted to check whether the communities that are invaded by Carpobrotus cynatiformis and Edulis were impacted the same or not. So we did a series of pair plots, meaning that we were sampling communities that were invaded by one of the two morphotypes, and communities that were analogous to those invaded, but were not invaded. Analogous meaning they were the same distance to the sea, and they were close, but not so close that they were affected by the Carpobrotus presence. So what we found was actually that there were some differences between the invaded and non-invaded communities, and essentially what we found was that it was a slight but significant decrease of species, of number of species. But when looking at the invaded plots, we didn't find any differences between the communities invaded by Edulis and the communities invaded by Aciniformis. And this was both when looking at the number of species per se and the diversity of species, of native species, of course. So we also went and looked at the Whitaker plots, they're called. So it's essentially the relative abundance of the natives and their rank. And we were so able to recognize which were more abundant and how much was the difference of this abundance. And essentially we found that, okay, in the invaded plots there was this increase of Elymus pactus, which is this species here. And when we're looking at the two different morphotypes, the communities invaded by Edulis were also having an increase of these native species. And this is probably because this is actually, it's a really typical species of the sand dunes, but it's also one of the most, let's say, ruderal ones. I don't want to say ruderal because it's not, but it's quite specialized, but actually it does well also in disturbed communities. And it also belongs to the most, to the beginning of the mobile dune. So it's also exposed to natural disturbances. It does quite good also in situations where there is a lot of environmental stress and natural disturbance and anthropogenic disturbance. So what we conclude in this paper that a master student published is that probably we were not able to test this with this data, but probably there's a slight difference in the distribution between the two morphotypes. So probably what we see here is essentially that Carpobrotus edulis might be able, or it's for some reason, it likes to live here, while Aciniformis doesn't have this preference. We then, of course, wanted to see, I'm a functional ecologist, so I was also concerned about the functional structure of the native communities that were invaded by these species. And we already knew, because of this work by the same lab in Rome, where I did my PhD, that actually there is a decrease of both, yes, taxonomic diversity and functional diversity in response to the invasion, so in response of the cover of the invasive, and that actually the species that were more, let's say, impacted, that were suffering the most, were those that had a low value of specific leaf area and low plant height. So we did have already some ideas of the species that were actually able to coexist with Carpobrotus, and which ones were not. But there was still some questions unanswered, and specifically there was this question about what about the intraspecific variation? Okay, we know that species that have certain traits are not responding well to the invasion, but we know that these traits and the species are able to modify these traits, the values of these traits, that they are plastic, especially height and especially specifically area. So I was wondering, because of this, this plasticity, let's call it plasticity, even though it's not exactly plasticity, but this intraspecific variation might be important for the competitive outcomes in a community. I was wondering whether there was some difference between the communities as seen through their potential trait values, let's say, so the normal values that are typically used in functional analysis, so the mean values in the best conditions, and what I call the realized trait values. So those values that are modified and that are actually a consequence of the competitive pressure of the invader. And of course, I went and measured a lot of trait values in species invaded and not invaded for both plant height and specifically area. I probably should say something more about these traits because probably not all of you are familiar with them. So plant height is quite straightforward. It's the it's related to the let's say competitive vigor of a plant, of a species, because the higher the plant, the more competitive it will be in terms of light. While SLA, it's actually telling us more about how the plant or how the species is using both water and light resources. Normally, species that have a high SLA grow faster and invest more on the, let's say, soft tissues. So the leaves live less and they are able to photosynthesize more quickly. While lower values of SLA are typical of those species of, let's say, more stressed environments. So these are species that grow slower, they have longer lifespans, longer leaf lifespans, I'm sorry. And they will, yeah, if you think about there is this trade-off of live fast, die young, and it will be those species that have higher SLA. While the lower SLA will be slower in growing and will live longer. So, as I said, I went and measured a lot of species in the field, invaded and not invaded, so communities. I did, again, pair plots, and I measured the actual traits of the species in the plots, of the individuals in the plots. And I found out that when, for example, for plant height, when I use the potential trait values, so the mean values of the individuals that were in the best conditions, so not invaded, there were no differences. I could not see any differences in the community-weighted mean of the plant height between not invaded and invaded communities. But when using the actual realized values, so when using values of the individuals that were not invaded and values of the individuals that were invaded, I actually could see those differences. And this was more or less the same. Oh, sorry, there's something missing. Anyway, it's more or less the same. You can imagine here the plot, I'm sorry. There were no differences when using the potential values. And this was not significant. We could see some small difference, but it was not significant anyway. The interesting thing was also to see on the single individuals, so the height values of the single individuals in all the plots were actually related to the Carpobrotus success or to the Carpobrotus invasion. So individuals tended to be higher across all species whenever they were coexisting with Carpobrotus. And also whenever the Carpobrotus invasion was stronger, let's say, or the cover of Carpobrotus was bigger on the plot. There was, of course, some variability in between the species. This is a linear mixed model. So I was actually using as a response variable the height of each individual, and I related it to the Carpobrotus cover, and I used species and the pair plot as a random effect. It means that for each species and for each pair plot, the main effect, let's say the line that you see here, was able to be lower or higher, and also was able to change its effect to become from positive to negative. And this, what you see here, is the effect of the species random effect, meaning if, when considering the single species, the main effect was getting a little bit more positive or negative, meaning that for some of the species, the effect stayed positive, so they were actually getting taller when Carpobrotus was more abundant. But some of them were actually, this effect was not so positive, was slightly less. So species were still getting higher because the effect was not big enough to turn this around, but the effect was not so strong. And this, for example, is for species that are already higher. Ammophila arenaria, I don't know if you've heard of it. It's a really tall grass that lives in the mobile dunes, and you see its effect is negative. So the next thing that I asked myself was, okay, we have this plasticity that is going on, species tend to be taller or lower, so it's actually linked to the success of the species, so it's a species able to coexist with the invader when it's able to change its trait value. And so what I tried to model was actually the cover of each native individual in the plots as a measure of its success, and the displacement. Displacement meaning that when comparing the realized value, the actual value of the individual in the plot that is invaded, with the potential trait value, is it getting higher or lower in stature? And unfortunately, this model was not significant, so it's still unclear whether this displacement actually translates into an advantage for the individuals, for the species, or not. So I did essentially the same for SLA, and strangely enough, this was significant. That's why we shouldn't trust p-values, especially on linear mixed models, but still, we saw how actually the SLA values of the native species was getting higher when Carpobrotus invasion was stronger, let's say. And also, as well, again, there was some variability of these effects depending on the species that we were considering. I also went and see if this displacement, this trait plasticity, was related to the success of the native individual, but again, it was not. So again, we don't know if it's actually an advantage for the native species or not. Oh, there's something wrong. Okay. Sorry. So I will tell you. So all the things that I told you before, there's still one question, one really big question actually. It's the changes that we see in the native communities. Are they really because of Carpobrotus presence? Because it might happen actually that Carpobrotus tends to be there because of these changes, but it's not actually producing the changes. And this is because, of course, we don't have a time machine, so we cannot go back and make sure that how the native communities were doing before the arrival of Carpobrotus, and we have to rely on this space for time substitution. So we have this pair plot approach where we sample the non-invaded and the invaded communities. A certain way of how to test the effect of Carpobrotus would be to do experiments, control experiments, where we have control conditions and when we see the actual effect of Carpobrotus. The problem is that to do experiments with these native communities is virtually impossible, because we have some really specialized species that have, for example, crazy root systems. Ammophila arenaria, this tall grass that I was telling you about, it actually helps build the dunes because of its root system that keeps that goes really deep into the soil, into the substrate. So to think about planting these species in a control experiment is virtually impossible. So a way, and sorry there are no pictures here, I don't know what's wrong with the presentation, but the where, one thing would be to somehow go back in time, although not physically, but to use, to combine the space for time substitution with diachronical studies, meaning using plots that were done in the same, more or less same communities in the same places, but before the invasion, before the introduction of Carpobrotus. In these areas, we know that Carpobrotus starts appearing in the 90s, especially in the southern part of Lazio region, where is our study area in central Italy. So we do have actually phytosociological, phytosociological releves from before that time. So we could actually combine the data from before the invasion, these phytosociological releves that go from 1987 to 2000, excluding, of course, this southern part where Carpobrotus starts appearing in the 90s, and the new pair plots. And we could also actually combine this information with information about the erosion of the coastline or the urbanization changes in these areas. Unfortunately, I don't have these results yet because, of course, there is a lot of, let's say, statistical and technical issues for dealing with this type of data. One, of course, is the fact that these plots were made with different areas. So we have plots that are 100 square meters, and these are normally 2 by 2 meters. So we cannot really confront them. Also, we don't have the exact position of these plots because we don't have the GPS points. So we only have an estimation of their position because of the locality that was described. But there are some techniques like bootstrapping and that will help us to do the comparisons, and I hope maybe to come here again later next year and present you these results. So to summarize, both of these, of the two morphotypes that are most common in Europe apparently have the same impact on the native communities, although there might be some differences in their distributions. This would be a topic to actually further analyze, not with this data that I have here, because for us to be able to analyze this, we will need some sort of random plots to actually test the distribution. These plots were not random. We were looking for Carpobrotus acinaciformis and Carpobrotus edulis, so there's no way of actually testing if they have different distribution or not. The communities, the native communities that are invaded by this species seem to have less native species, are less diverse, and have also functional diversity. They tend to have, apparently they tend to modify their traits the species that are able to coexist with Carpobrotus by being taller and having higher values of SLA. But it's not clear if, so yes, this is also going with the competitive pressure of Carpobrotus, but it's not clear whether this actually gives the natives higher fitness or not. And of course, we need to further analyze, as I said before, these changes by confronting them with previous situations, with previous, before the invasion, to be able to disentangle this driver versus passenger question. And that's it. I leave you with this kind of weird postcard from Sardinia. And I thank you for your attention.
So, thank you. Thanks a lot for your presentation, for your interesting research. And now we have a time for questions. I really enjoyed the measurement of the functional traits using those optima and those true ones. It was nice for me. So, yeah.
So I actually have a question concerning this experimental evidence, because it's really I really have an issue with this observational type studies, because if you have two plots, invaded and non-invaded, okay, even if you try your best, you never know whether there is not another confounding factor, and you never know whether this non-invaded could be invaded or not. That's the problem. So if you place them, if you place these plots as close to each other as possible, which is one strategy, then usually there is this contrast. Why actually is that one invaded and the other not? So you don't know. Maybe the other one, not invaded currently, might be invaded in the future, but maybe not. That's something because of some environmental
this is actually a plant that it doesn't have any problems to live anywhere. It's really, really a strong plant. So I guess all of the non-invaded plants, they can be invaded, especially because we actually wanted to preserve the same environmental conditions. So we took care of placing them not only at the same sea distance, but also at the same exposition, because these dunes make it quite tricky sometimes that if you, for example, are exposed to the sea wind, if you are facing the sea, you might have another area really close to it that is not exposed because it's on the back of the tube. But actually we took care of this when doing the sampling. The thing is, of course, as I said, the only way of actually quantifying the impact is to do experiments, but unfortunately with this type of systems it's really tricky.
And what about, okay, when it comes to this experiment, what about doing reading experiment?
Yeah, I didn't talk about that, but you're right. This is another way of seeing you kind of have this after the invasion, so how the community actually recovers.
Yeah.
But the problem here is that to do a weeding, because of the substrate, is actually really disturbing. So we wouldn't know if the effect that we see, the differences that we see, are because of this disturbance or not.
Okay, you would need to wait.
That's also why why this plant is not being actively eradicated in some areas, because that would be to take it out from the sand. It's actually destroying the dune. So we actually tried in our lab to do some weeding experiments, but first of all, practically it's really energy and time consuming because
Experiments are always like that.
no, but it's also because of the nature of these plants that you might think that you take it all out, but then actually you maybe just there's one rabbit that you didn't see and then it grows back from there. And also the fact that it has strong effects on the soil. So we don't know how much time, for example, we will need to wait for these effects to go away.
But
maybe can we give space to another round and thank you.
But we can talk about it later.
Yeah.
Well, I wanted to react to this topic, may I?
Yeah.
So, no, I just wanted to ask you, not Luisa. So I see the issue with bird plots, but what is better? What's the suggestion? I think that's the best option you can do if you wanna study the impact of some invasive plant on a community. Because it's I think it's easy to say that there are problems, but what would be better?
well, this is just the first step, I would say. Like,
Yeah.
of course, as a first step, it makes perfect sense. But then it's you shouldn't really.
Yeah, because if there are no differences, then it doesn't make sense to do anything
Right,
else.
But even like one suggestion, which I think you could do, and would actually address my objection, is actually to try transplanting the Carpobrotus from the invaded plot to those which were not invaded. And if it is able to grow there,
It could totally.
then
No, but the question is not why is it the Carpobrotus there and why is not on the other place. This is not the question. The question is whether the species that are...
okay, but this is an assumption which I can believe you or not. It's like, you don't have data for that statement. For the statement that Carpobrotus could invade the control site. You don't have data for that.
If the control site has the same environmental situation.
Okay, and you measured like everything. Did you? So did you measure like everything, like soil conditions, everything?
It doesn't have a specific conditions that it requires to grow. It only needs space normally and just to arrive there. If I put it there,
So why,
I have it in my balcony, for example. I have it in
so why
it really grows everywhere.
Okay, but clearly not, because it's like there are still many sand dunes where Carpobrotus doesn't occur.
But I think we are you answered.
No, but because that's another question. That the question there that you are asking is why is here and why is not there. And this is a totally different question. I'm interested in where I find it, what is causing to the native plants. You know what I mean?
Yeah, you are interested. What you showed is the difference between sites where Carpobrotus occurs and where it is absent from.
Yeah.
Which actually is not the same. It's correlative statement. It is not the same as the statement what actually Carpobrotus does to the vegetation, because that is a causal statement which you can only do that can only be based on experimental evidence.
Yeah, I know, but as I said, this is the next best attempt to try to understand what it's doing.
Okay, I just think that this could be somehow strengthened.
Yes, I have actually two questions. Thank you very much for the presentation. One is like, because I'm also from the Mediterranean area, and I know Carpobrotus a little bit. And then one of the conclusions, if I understood well, of your work is that in invaded plots, native vegetation is higher. Well, it tends to be higher. So I wonder if it really means that, the idea that comes to my mind is that you have taller plants when there's Carpobrotus. But But I wonder if that is so, or you're actually seeing that the variance of height, of plant height, is actually like decreasing, and because of that, you see that the values are also higher. So I think like a way to you show the results for community weighted mean, but like I think you should probably look at community weighted variance as well, because I have like you might have arenaria, Amophila arenaria, and then like many other natives, and Carpobrotus comes to the community, removes the lower natives. I don't know if that's the case, but it might remove. So you don't have like natives that are very low. You have like only those that are higher, and then because of this, you are seeing like higher highness in this case. And there's no increase. It's just that you're removing the lower. The variance is getting lower.
Yeah, definitely agree. When you think community weight means the differences could be due, in this case, because I use different values, could be due to the actual values and could be due to the differences in abundances of the native species, because these are weighted means. That's why I did the other models, and these models were based on the single measures of each individual, and therefore I'm saying that when the species is in the not invaded and the invaded communities, actually there's a shift in their trait values, and it tends to get to be their height is they tend to be taller. The same species. The individuals that are invaded are taller than the individuals of the same species that are not invaded. So of course, when you see the community weighted mean, you don't know if it's, as I said, difference in the native composition of the communities or the actual values, and that's why I did the other models were based only on the trait values.
Okay. And sorry, the second question is more about can you tell us about the legal status of Carpobrotus in Italy? Are people allowed to plant it? Is it present in nurseries?
I'm not sure if it's present in nurseries. I don't think so, because it's considered invasive. In certain areas of Italy, not in all regions, because it's based on the region. For example, in Lazio region, it's considered invasive, but if you go to the Adriatic coast, it's not considered invasive because it tends to die over winter. But still, people keep planting it, and it's really easy to plant because, as I said, you just take a ramet, put it in the soil, forget about it, and then you have a really healthy growing plant. So people like it, and they tend to plant it, especially when they have houses by the sea. They like to have it in their gardens. So there's a lot of propagation pressure for this plant.
Luisa, may I have a question? You compared two species of Carpobrotus. You said that you can distinguish between them in the Lazio. But if you are going to the field, could you also see differences in ecological preferences of those species, or some different habitats occupied?
What we see.
Why you studied it?
Yeah, the thing is that in our lab we were studying Carpobrotus since a lot of years, and we were tending to put the two together, the two morphotypes. And since there is a little bit of differences in their, well, of course, in their leaf anatomy, and also in how apparently Aedulis has a more, it's more able to, how to say, it's more vigorous in its clonal spreading. We were wondering if we were doing the right thing by putting them together or not. So that's why we did that study. And what we say actually in that study is that there might be preferences in how they are distributed, so differences between the two morphotypes in how they're distributed along the zonation. But this is only based on our field observations. Like, whenever we found Aedulis, we found it on this mobile dune on front of it, so more exposed to the sea. And while Acinaciformis was almost we could find it even in the Macchia, so between the Juniperus and but this is only based on our observations, so we didn't
don't have plots.
What we would need to do to really test this assumption would be because we have a map of all the Carpobrotus patches, and we will need to update this map to assess which of these patches are actually acting as formies or which one are envies, and use this map to assess if there are these differences in how they distribute around this nation. But we haven't got that yet.
Yes, I was wondering whether you know something about ecology of these species in their native range. So, do these two species of Carpobrotus occur together in South Africa? In which habitats are they growing there? And whether they are also able to do such vigorous growth, yeah, with 100% cover of ground like in the Mediterranean.
Yeah. I think they are both widespread in coastal areas as well in South Africa. I think they occur also elsewhere, like they're not specific of coastal areas. I'm not sure. And I think yes, essentially, because they are both really vigorous, but probably they have more different competitors in their home range. So maybe they are not able to be so to cover that much of the space.
Thank you, Luisa. I have two very general questions. One is related to the eradication of these plants. Because you mentioned that you are trying something to understand like which is the best solution. I knew some technique that they use for opuntia, yeah, so still fleshy leaves, but it's not instantly, but anyway. And they basically cover with this black plastic bag, and they make the plant mulch-efficient. So they don't have to physically remove plant by plant. Do you know if this might work on this as well?
Do you know that they were using it on the seaside?
I don't think so. I know it's somewhere in the Canary Islands. So
because that's one of the issues that in the seaside you have the effect of the wind, especially in winter, and it can get very strong. So I'm trying to think if this, like putting these bags, which in this case is not like you have the same grow form as in opuntia. You have this mat like creeping plant, so you will need to put like some sort of carpet on it, some sort of like just a piece of plastic on top, and to secure that so it doesn't fly away. It could be done, I guess. I'm not sure if then it will be detrimental for the organic matter that would be still touching the ground and would stay actually in the ground unless you dig it up. So, I don't know. I think, unfortunately, there's not much. I'm really pessimistic about this plant. There's not much, a lot of things, like there's not much to do to eradicate it. It's just there. And actually, the attempts that we have made to take it out have been actually worse. And I think the problem here is not, I think this is, if you want to take, to see the big picture here, this exotic problem, especially for this particular species, is not the biggest problem that we have in the coastal areas, especially in central Italy. Like, that's why I would really like to go on with this research, even though now I'm doing totally different things. But because I think to really test this driver and passenger hypothesis would be good, because probably we will see that the endangered communities are already reaching
part of the physical space of the dunes. Like when it's really invasive, okay, there are many other disturbances, but all the physical space it's occupied is very...
Yeah, I think it would make sense to try to contain it, at least maybe not eradicate it, but contain it in some areas. For example, this natural park in the southern part of Lazio region, Cicteo. I don't know, there's this area called Sabaudia, and it has really nice preserved dunes. But this guy, together with erosion, are really ruining these dunes. So in that case, for example, it would make sense. But in other places that are already disturbed and that you really have communities that are not doing well anyway because of other pressures, then probably doesn't make sense to take it out.
So, may I have a question, very trivial one? You choose two traits, the high and SLA. But for me, it has very attractive flowers, so I think it's attractive for pollinators. And if the native species are also somehow annual and needs to be pollinated, so insect pollinated, they should be affected somehow, probably. Why you didn't study this, or is it known how it works?
So there is this paper cited, it's Carpobrotus, and they were actually seeing that pollinators tended to prefer, and it's actually from my field memories, I also remember seeing a lot of pollinators on Carpobrotus. That doesn't prevent the other species to be pollinated at all, but it's still probably, there's for sure some sort of competition going on. I was interested in this plasticity or intraspecific variation issues, and these flowers are not so plastic. So.
Yeah, but there could be a number of ramets, so flowering ramets, number of flowers on the plant. Imagine if you have a big competitor, you have either to do more flowers to be somehow also competitive, or you can shift phenologically, or you can disappear.
Yeah, that would be more about the reproduction strategy, probably. That would be, of course, interesting to see if there is some sort of adaptability of the species that are coexisting with Invasive, with Carpobrotus. But I was mentioning so many individuals that also the problem with these flowering traits is that is really depending on the phenology of the species, and so also the campaigns are time consuming, of course, like with everything. But
The next question.
As it's also partly shown in this picture, it grows also on rocky places, on coastal areas.
Yeah.
So do you plan also to study the communities there, or how these invasive species react in some, I don't know, specific traits on different substrates?
This I haven't thought about it, to compare the effects on these rocky shores. The communities are really different, so there's no point of comparing the native community. I think, from what I know, it's that probably Carpobrotus in these rocky shores is actually beneficial somehow because it apports a lot of organic matter, and so it's competing for the space essentially. But I think that actually it's changing the ecosystem in that case, in the sense that probably the species that are able to grow with it are ruderals and not anymore the specific species of these rocky shores. But we haven't done any plots on cliffs yet. So
Next
time, I don't know. You should talk with Alicia.
Just technical question. When you were sampling, were you always able to distinguish the two species? Yes? Because this Acinaciformis can be both yellow and red.
So essentially, Acinaciformis has always the red petals, and really, even the leaves are different.
So you can identify them even if they don't flower, based on
the leaves. Yeah. Okay. Yeah, and Acinaciformis, you're right. It can have the flower can be all red as well, but actually I've never seen that in Lazio.
Are there hybrids?
The thing is, apparently this hybridization process is quite common, and apparently in Europe, Acinaciformis alone doesn't exist. It's there's some introgression of edulis in the populations of Acinaciformis. So the thing is that you can still recognize the two different morphotypes, and we haven't done the genetics on the population, so we don't know exactly. What we did do was try to get individuals that were not close together. Like when we were comparing and doing the plots of edulis and Acinaciformis, if they were nearby, we were excluding those patches. We were trying to avoid this overlap of presence, let's say.
I have some stupid questions. Do you know why the English name is Iceplant?
I don't know. Actually, the name in Italian is quite fun because it's called Figo degli Ottentotti. And
it's called like that in South Africa, I think, Hottentot fig.
I'm not sure if it, but I know that it in Italy we call it like that because of the this Hottentot population. They apparently are not from South Africa, but there is like this. When it was first introduced, it was thought that it came from this other region of Africa. I'm not actually sure. Asia, I'm sorry. I don't know the exact story, but essentially it's because of the fruit that it's edible. And it was compared to this fig. So yeah, Iceplant, I think it's because of the leaves. Iceplant is a general name for all this family actually. So I think it's because of the leaves that are kind of like, in this case not so much, but in other species of the same family there is this, they have kind of like, they're almost transparent. You're just really full of mucilaginous, I don't know how to pronounce it, gel essentially. And so it almost looks like eyes, I don't know, probably something on that line.
So once again, many thanks for coming.
Thank you for inviting me.
A příští týden máme seminář v češtině k nedožitým narozeninám profesora Víkerka. Bude soubor přednášek, které shrnou, čím se zabýval a jak vlastně na jeho výzkum navazuje současný ústav.